Today we'll verify the trigonometric identity that secant squared theta minus tangent squared theta equals 1. Let's break this down step by step using fundamental trigonometric relationships. Let's start by recalling the definitions of secant and tangent in terms of sine and cosine. Secant theta is 1 over cosine theta, and tangent theta is sine theta over cosine theta. Now, let's square these terms since our identity involves secant squared and tangent squared. When we square secant, we get 1 over cosine squared theta. And when we square tangent, we get sine squared theta over cosine squared theta. Let's substitute these squared expressions into our original identity. We now have 1 over cosine squared theta minus sine squared theta over cosine squared theta equals 1. These fractions have the same denominator, cosine squared theta, so we can combine them. This gives us 1 minus sine squared theta all over cosine squared theta equals 1. Now here's where we can use the Pythagorean identity. Remember that sine squared theta plus cosine squared theta equals 1, which means that 1 minus sine squared theta equals cosine squared theta. Looking back at our equation, we can see that the numerator 1 minus sine squared theta is equal to cosine squared theta. So we have cosine squared theta over cosine squared theta, which simplifies to 1. And there we have it. We've verified that secant squared theta minus tangent squared theta equals 1. To visualize this relationship geometrically, let's look at a right triangle on the unit circle. The secant represents the distance from the origin to where the angle's terminal side intersects the circle, divided by the adjacent side. The tangent represents the ratio of the opposite side to the adjacent side. This geometric relationship helps explain why secant squared minus tangent squared equals 1. And that completes our verification of this important trigonometric identity. Remember, we can verify it both algebraically and understand it geometrically.